Hey everybody, excited to share the InvokeAI 3.2 release. We have some really exciting new features that we'll go through on the video, and I'll give a quick tutorial on how to use one of the new features, image prompt, to add more diversity to the generations that you create. So let's dig in. First, in Invoke 3.2, you'll notice that the UI has shifted dramatically around our Invoke button. And that's because we've added an entire queue management system to both the linear, canvas, and workflow user interfaces. What that means is when you add any number of generations, they'll be processed one by one in a queue. So let's go ahead and do 10 here. I'll hit invoke. We'll see that it adds 10 sessions to the back of the queue. And I can click into the queue tab to see all of those images get processed live. You can also call out where there were failures. This is a great way to set up a couple of different generations and have those processed in sequence. It also allows you to vary both your prompt and settings and queue those up. So if, for example, you wanted to queue up an image to image and have 2 or 3 done at a denoising strength of 0.9 and then a couple of others at 0.7 and maybe one at 0.5, you can do that, queue those all up, and have those processed in order. Now that we've talked about the queue, let's dig into another addition in 3.2, the Tiny Auto Encoder support. In the release notes, you'll see a link to the TAESD model. This is a VAE model. And what the TAESD model, or the Tiny Auto Encoder model, does is decodes latents in a much more efficient manner at the expense of a few minor details. So let's actually take a look at this with a new seed. We'll go ahead and generate this. One thing to note is you'll want that to be an FP16 precision when you use this model. And we'll go ahead and generate this image. Actually, I only want to generate one, so I'm going to clear out the rest of this now that that's generated. So we've got this robot that's been created here, and the decode step was much more efficient. To compare, let's take a look at what the image looks like when we use the normal VAE. So you'll notice the image is largely the same. There's a little bit more saturation on the Tiny Auto Encoder, but overall the image quality is pretty comparable. Now, I personally will probably continue to use the larger VAE for the tiny enhancement in quality, but if you're primarily going for speed, the Tiny Auto Encoder is a great way to generate a lot of images more efficiently and then go back and regenerate the ones that you want to see that additional detail with. Now, what you'll also notice is that when I regenerate this image a second time, it's going to generate instantaneously. And that's because on the back end, we've added a new feature called node caching. And what node caching does is if there are any steps in the process, whether on the linear UI or in our workflow, that are repeated in a future run, we don't do that process again. We actually save that node state so that we can reuse its information in a future run, making it more efficient. So I'll give a shot here. I'll just generate one image, and you'll notice it just immediately generated. Now, this isn't a new feature in 3.2, but something that I figured I'd call out on this video because I've seen a lot of questions come up around it, is the multi-select in the gallery. So I've generated a lot of images here. I don't really want to keep any of these. It's no offense to any of these robots. I just am going for something else. So I'll use the shift key. I've got my first item selected here. I'll use the shift key and then select the bottom item. All of those have now been selected, and I can right click and delete those images. Now I'll head to my 3.2 release board and take a look at the image that I was trying to go for. This image here has a much more gritty, illustrative vibe than I've been getting in all of the generations that I had. And I want to use this image to help the system understand what I'm going for. So we'll use the new feature called IP Adapter. And what IP Adapter does is it allows you to take in an image. I'm going to turn that ControlNet off. It allows us to pass in an image and use one of the IP Adapter models to use the concepts in the image and the styles in the image to help guide the generation process. Some people have asked me what the difference between image to image is and IP adapter, and I think the simplest way to explain it is that image to image uses the color and the structure of the image to guide the generation process, because you're manipulating the data that the denoising process is taking place on top of. With IP adapter, instead what's happening is the image is being turned into a prompt. It's being turned into the conditioning data that is guiding what the model will generate. So it's not impacting the noise directly. Instead, it's almost like it's turning the image into its conceptual essence and using that in the generation process. Now, one thing that I'll call out is that if there are specific concepts or a particularly complex image, the machine learning model that is doing that process doesn't always do that perfectly. However, most of the time, you're going to get the gist of an image pretty well when you're using it. In fact, it's so good at doing what it does that you sometimes don't even need a text prompt. So let's go ahead and take a look at what happens when we generate without a text prompt at a weight of 1. So you'll see it picked up a lot of the content from the image, although I'm pretty sure if we use a text prompt, it probably guide it better towards the style I'm going for. Now, what we used here is the IP adapter model. There's actually an IP adapter plus model. It would probably be incorrect to say that the plus model is just a better IP adapter, because I don't think that's necessarily the case. Instead, what you'll find is that the IP adapter is focused much more on fine-grained details in the image. So while with the basic IP adapter model, we got a kind of general illustrative robot, with the plus model, we're actually going to look at the fine-grained details of this image, such as position, how it's postured, where it's located, and much more specifics of what is in this image. So let's go ahead and take a look at what that looks like, again, without a text prompt. So you'll notice that even without a text prompt, we got our eyes, we got our yellow robot. It even has this kind of like barrel in the chest. And it's picked up a pretty decent amount of the style, although it's, again, not perfect. What I want to do now is I'm going to decrease the weight of this to about 0.6, and I'm going to add my text prompt back in. And we'll take a look at this. Again, we're on the same seed, so we should see the exact change in generation that this tweak makes. This is a really, really cool tool. I've had a lot of fun with it. I definitely encourage you to take a look at it and use it. Now, if we want to get a little bit creative, what we can do is decrease our IP adapter model even a little further here. I brought my weight down to 0.3 so that we can play around with the loose concept of this image that we're passing in, but give it a much more flexible prompt. In this case, we'll go with a trash can. I know, wildly different, but what we'll see is that our very basic prompt takes a lot of inspiration from the IP adapter, and if we've given it enough flexibility by bringing that IP adapter weight low enough, these two will kind of fuse together to create a new hybrid image. So now we've got our robotic trash can. It picked up a lot of the style from our original image here, this kind of illustrative look and feel. And it also picked up that yellow kind of robotic looking concept as well. So what I'm going to do real quick is I'm going to turn off and clear out my prompt and my IP adapter. And I'm going to generate the face of a man for use in the next IP adapter model. So we'll use the face of a man named Jacob Berlin Odemeyer. We've got this gentleman here with this very nice mustache. And we're going to use this in our next image. So we'll turn IP adapter back on. And then now I'm going to use the IP adapter plus face model. Now what the face model allows for is using a character's face. Let's say you're a concept artist and you have a character that you want to use in a different pose or in a different scene. You can pass the face into the IP adapter plus face model and have that inspire the generation, specifically focusing on the character's face. So now what we'll do is we'll create a character concept art. Now, I think we got a little bit of the face there, but I want to go ahead and do a close-up here. But I'm also recognizing that we left the weight down at 0.3. So let's go ahead and bring that back up to 1. There we go. That looks a lot closer to our gentleman. Let's go ahead and do a couple of random seeds of this and see what we get. I've noticed that when the weight is at 1, sometimes it can cause some deterioration in the quality of the image. So we may turn that down and toy with it just to see what we get. Yeah, so that's decent. Play around with it, see how it works for you. I find myself playing around mostly with the other IP adapters just because the conceptual potential there is really, really cool. One last update that we'll talk about is dynamic prompts. In 3.2, you no longer need to turn dynamic prompts on. It's just automatically calculated for you. And when you use it, each of those dynamic prompts will be batched automatically into the queue. So in this case, if we do our prompt as not just a desperado, a sheriff, but also perhaps a winged owl creature and a shadow ninja mage, we can see that each of those prompts is automatically composed for us. We can choose to do seed per image or seed per iteration, and we can also increase the number of iterations. Now, since I've got 3 prompts here and 3 iterations, if I were to invoke, this would queue up 9 different sessions, 3 times 3. So I'll do one for each of these, and we'll go ahead and invoke. Aside from those big features, there's been a lot of cleanup in the canvas and the workflow editor. There's been a lot of improvements in the workflow editor specifically. So we'll go ahead and start with a main model node, and we'll pick our Invoke Fantasy and Art model. From any node, if I drag and drop a connector, the node creation screen will display. You'll notice that only valid nodes that would connect to that UNet field are displayed. So I can very easily get to my denoise latence node if I want to pull out positive conditioning. I've got all of my primitives here, including my prompt. So this is a great way to really easily get through and create a graph super quickly. You're also able to now click near the edge of an existing node once selected and move that connector around. And that applies to both the end and the beginning of any connector. The last addition that I'll talk about today is the use cache checkmark at the bottom of the workflow. By default, everything is going to use that node cache that we talked about so that it doesn't reprocess the content. But if for whatever reason you want to make sure that that is not cached and that that node is always reprocessed on your workflow, you can turn that off. With the addition of the queue, you can now run your workflow for as many iterations as you'd like using the slider or the text input, and those will get added to the queue just like any other job in Invoke. Those are the big features for 3.2, but I encourage you to read the release notes because there's some more details and documentation that you can review to learn about everything that's come out with 3.2. As always, today we covered the community edition of Invoke, but most of these features are available in the professional, hosted, and enterprise versions of the tool as well. Stay tuned because there's more coming. And we're excited to continue making Invoke the best way to deploy Stable Diffusion, whether you're using it locally as a creator or with a professional creative team on our hosted pro-grade product. We're excited to see you realize your creative vision, and we'll catch you in the next video. Like, subscribe, comment, do whatever you want. We'll see you soon.